If this looks confusing right now, don't worry. You might see a bunch of sticks joined together, or if you have a creative mind, you might even see an illustration of a dog. So what is this? Should we take a look at another one? Do we see three people oversimplified of this photo, which obviously shows a lot more detail? So these lines are not just random, they are called skeletal formula of a chemical structure that's simplified for the chemist. So what does it actually look like? Each corner represents carbons, and there's another, and there's another, and it even shows hidden hydrogens around the carbon atoms. In this video, I want to share the easiest and most visual way for you to recognize and draw the structures of alkanes and alkenes effortlessly, and you will become a master of naming them all within the next 15 minutes. When it comes to naming and drawing organic compounds, there are a few things to consider. How many carbon atoms are in the main chain? And feel free to capture this table, which shows the number of carbons and the prefixes, the name of the organic compound that starts with. Second, we need to recognize the functional group. Sometimes it's called nomenclature or homologous series, but let's not worry about those terminologies right now. For example, if it's an alkane, the name ends with ANE. If it's an alkene, it ends with ENE. So if you look at a butane, but represents 4 carbons, and ANE suffix means it's an alkane with 4 carbons. If it happens to be an alkene with 4 carbons, of course we'll be calling this butene. What about if it belongs to an alkyne family? You guessed it right, it'll be called butyne. And there will be more functional groups such as alcohol and many more, which is going to be covered in my next video. Lastly, if there are any side chains that are dangling off the main chain, we also need to address them too. So let's begin. So in this video, I'm only going to focus on alkanes and alkenes to give you the basic system of the naming. Alkane is the most basic structure of the organic compounds. It is one of the hydrocarbons, meaning it only has carbon and hydrogens. And it's characterized by C to C single bonds only. And don't forget, each carbon must have 4 bonds. So each carbon should be connected or covalently bonded with 4 other atoms. And because it's got a full number of atoms bonded to it, it is called saturated with a general formula, bit of a math, CnH2n plus 2, which means double then plus 2. So when you have 4 carbons, such as butane, it's 4 times 2, 8, plus 2, 10. If it's 6 carbons, 6 times 2, 12, plus 2 becomes 14. So I'll be using C6H14 to draw different structures of alkanes and show you how to name this, and you will never get it wrong again. Here we have 6 carbons accompanied by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I feel like a gym instructor now. So 14 carbon will be the maximum number that could be accompanied by 6 carbons. So having 6 in the main chain, we start with a prefix hex. And there's C to C single bonds only, which belongs to an alkane family. So bring the suffix ANE to represent the alkane, and it is called hexane. And there's another way to represent this formula using something called condensed formula. Pretty much the same structure without drawing the covalent bond using sticks. So it is just reading from left to right, starting from CH3 on the far left, followed by CH2s. And we can even condense this further. Check it out. There's CH2 group once, twice, 3 times, and 4 times. So by using the brackets, we can make the simplest condensed formula. So for the next one, we'll have 5 carbons in a straight chain by putting the last 6th carbon somewhere else. And this becomes a side chain. So should we add and check to see whether there are 14 hydrogens? There's 3 here, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So no matter how you draw the structures, 6 carbon should have 14 carbons if they belong to an alkane family. So let's find the longest chain. We only see 5 carbons, which will be pentane. Then this CH3 becomes a side chain, and having only 1 carbon, this will have meth in here. Did I hear you right? Meth? By having this YL at the end of meth, it represents 1 carbon is a side chain. So YL represents the side chain. But this side chain can be anywhere. So it's important to number the main chain, starting from the side that's closer to the side chain. So we would have number 1 carbon to the left, since the methyl group is closer to the left-hand side, and number the main chain. And that shows the side chain happens to be on the second carbon. So here's a location showing 2 methyl. Doesn't mean there are 2 of this. This means methyl group happens to be on the second carbon of the main chain. So this is called 2-methane pentane. 2-methyl pentane, beg your pardon. So the next structure still shows 5 carbons, but let's move this methyl to the middle by sliding it to the right. And I won't be bothered to do the hydrogens here. And you got it. This has 5 carbons in the main chain, so still a pentane chain, but the methyl group is on the 3rd carbon, and you can count it from left to right or right to left, since this is in the middle of the chain. So it is going to be called 3-methyl pentane. Okay, so let's have a look at the next structure. We have 4 carbon, but if you have another carbon at the end of the chain, this may appear to be a side chain, but in fact, this will elongate the chain and come back to the pentane family. So don't be fooled by the way or the angle of the carbons are drawn. So the mission is to find out the longest consecutive carbons that are drawn in a straight line. It doesn't have to be a straight line visually, but it has to be connected to each other. So same goes with this. If you have 3 carbons in the middle, 1 on the top, 1 at the bottom, it may look like side chains. You got 2 of those, but in fact, that's still a pentane family. So don't be fooled by where it's drawn. So let's get into the right one. So having real 4 in the main chain, now we're going to put the side chain not at the end, but somewhere in the middle, but I'll be adding another one to make it up for 6 carbons. So 3 hydrogens, that makes 6, and there's 7, 8, 9, 10, 11, 12, 13, 14, there you are. And the main chain now has only 4 carbons, because that's the longest chain here, and that'll have a prefix of bute. This writes as but this reads as bute. And having C to C single bond belongs to an alkane family. Remember, we are only covering alkanes and alkenes in this video. And the remaining 2 carbon becomes the side chains. And since we have 2 of the same methyl group, we call this a dimethyl. Di represent 2 of those. So we got 2 methyl groups coming off separately, and time to number and give them the position of where they are. Remember to count from the side that's closer to the side chain, and we're counting from the left. There's 1, 2, 3, 4, and both are coming off the second carbon. So we put 2, 2 to give them the location for both. So it's called 2,2-dimethylbutane. So it sounds quite long, but once you break it down to which one represents which, it is actually quite logical. I want to try another one. So sticking with 4 carbons in the main chain, 1 side chain here, 1 side chain there. This time I'll slide one of them to another carbon. And find the longest chain will still be a butane, still have dimethyl group coming off, because you've got methyl here, and you can count them from which side ever, because they're equivalent in this case. So there's 1, 2, 3, 4, and one's coming off from the second carbon, one's coming off from the third carbon. So it is going to be called 2,3-dimethyl. I've been teaching for many years, and one of the frequently asked questions is how to distinguish something called dimethyl or ethyl. So let's imagine this long chain as a carbon, and when you have one carbon coming off, this is going to be a methyl group. If you have two of those coming off, this is called a dimethyl group. What if you have two carbons coming off as a same branch? This is when it becomes an ethyl group. Let's try another one. If you have ethyl and methyl coming off, you cannot combine them together because there are two different types of side chain. So we're going to prioritize the ethyl, give it a number of the location, and methyl gets treated separately. Are you ready to move on to something complicated? So I'll be using examples that has more than 6 carbons. In fact, there will be 8 carbons altogether. So let's use the general formula to count the number of hydrogens. So C8, 8 times 2 is 16, and plus 2, so it'll be 18 hydrogens altogether. So let's add the ethyl group and the methyl group, and trust me, there will be 18 hydrogens around, still with the main chain having 5 carbons in a row, so this belongs to a pentane family. So let's address the side chains. So there's a methyl group and the ethyl group, but since both are in the middle of the chain, we can count them from left to right or right to left. It wouldn't make a difference. So let's start with the left to right for the convenience. So there's 1, 2, 3, 4, 5, and methyl group happens to be on the 3rd carbon. And same goes with the ethyl group. So ethyl becomes on the 3rd. So 3 ethyl, 3 methyl, pentane. And the next one, it'll be the same strategy, but I'll be sliding one of those groups to somewhere else. So ethyl group happens to be on the 3rd carbon still, but this time it has to be counted from right to left because methyl group is closer to the right hand side of it. So we always count the main chain from the side that's closer to the side chain. So there's your number 1, 2, 3, 4, 5, and 3 ethyl stays the same, but the methyl comes off the 2nd carbon, so it is called 3 ethyl, 2 methyl, pentane. So having more carbon in the side chain doesn't mean it gets prioritized and get to be written at the front. It is going by the alphabetical order, which I'm going to cover a little bit later, so hang in there. Okay, let's come back to the skeletal formula that you've seen on my first slide. So there are 5 carbons on the left-hand side. I'm looking at the structure on the left. So 5 carbon. And I normally draw 5 dots there to represent 5 carbons, then start adding sticks to it because it is really easy to draw one more or one less stick. So by drawing dots, we'll make sure when to finish. So that represents the pentane main chain, and the methyl is on the 3rd one, ethyl goes on the 3rd one, so it looks like this. So let's do the skeletal formula for the next one. So same drill, 5 carbons representing dot, then accompanied by the stick. Then we have a methyl group on the 2nd, ethyl group on the 3rd. Now you should be comfortable with methyl and ethyl, but check this one out. We got a pentane chain, but I'll be adding side chains here, side chains there, and one more methyl side chain. So let's add all the hydrogens here. There you are, and still having pentane as your main chain. But do you notice there are 3 different three actually separate methyl groups, and I even tried to give you a clue by putting them in a shape of a triangle. So we have methyl 3 times. So you guessed it right, it is a trimethyl, and let's give them the location of it. Since it's quite a symmetrical structure, again, it doesn't matter which side you count from. So I'm going to count from left to right, and methyl group is on the 2nd one, 3rd, and 4th. So this becomes 2, 3, 4 trimethyl pentane. Easy. What about this? So when you have methyl here, methyl there, same as, but I've slid the methyl to another carbon. And since methyl groups are closer to the left-hand side, there's your numbering system. It becomes 2,2,4-trimethylpentane. All right, last option is to have them like this. What would you call this? We need to count from the right to left in this case. So let's add all the hydrogens because I felt guilty for not having hydrogens in the structure above. So we need to go from right to left, and the side chains happens to be on the second one, second and third. So it becomes 2,2,3-trimethylpentane. This is your turn to find out the longest chain. Make sure you don't get fooled by where it's been drawn. Don't always look for the horizontal representation of a carbon. You need to explore and try to find the longest chain that has the most number of carbons. Now you guessed it. There's your longest chain having 6 carbons in a row. And this carbon comes off as a methyl chain. And remember, the IUPAC naming has to have the side chain that's closer, which gives you the smallest number. So if you count from this carbon, the methyl group comes off the third. Should we check out what happens if you count backwards? So if you go from the other end, we will have the methyl group on the 4th carbon, which is larger than 3. So that's not our option. So having 6 carbons in the main chain will be a hexane, and the methyl is coming off number 3. So this becomes a 3-methyl hexane. I hope you feel comfortable and confident with drawing alkanes and naming alkanes. So it's time to move on to alkenes. This is a second class of hydrocarbon, meaning it still has only carbon and hydrogens, but this time there will be C-to-C double bond. It may have one of them or a couple of those or 3, but we'll be covering that a little bit later on. And because of this C-to-C double bond, it will have 2 less hydrogen compared to alkane with the general formula of CnH2n. So it's doubling the number of carbon will get you the number of hydrogens. And since it's lacking hydrogen, we say it's unsaturated. I have this image of the Google, so thanks to Textbook, which I'm using it as a reference. So for those of you who are taking biology, you might recognize the name fatty acid. So if you have a saturated fatty acid, it has C-to-C single bond, which represent the saturation. And if you look at unsaturated, there is a C-to-C double bond along the way. So more C-to-C double bond there are, more unsaturated. So it can actually become monosaturated for one C-to-C double, polysaturated for multiple C-to-C double bonds. Now, when it comes to naming alkenes, it is very similar to an alkane, but it depends on the location of the double bond. So we got 5 carbons in a row, and carbon should have only 4 bonds around. So this carbon has 2 hydrogen. This carbon, second carbon, has 4 bonds already. So there will be all the hydrogens added in. And having 5 carbons in a straight chain, the straight chain must consist of C-to-C double bond. It must include that because that belongs to an alkene. And numbering, having 5 carbons, we'll have a prefix of pent, and we have to number from the side that's closer to the C-to-C double bond since it's an alkene. So the double bond is happening between C1 and C2, and we go by the smallest number. So we'll choose number 1, and this is called pent 1N. And what if you change the location of the C-to-C double bond, which happens to be between C2 and C3, and choosing the smaller number, we'll have to go by pent 2N. And I won't bother to do the hydrogens. And they both have molecular formula of C5, doubling the number of carbon, which will give you the number of hydrogen. So both should have 10 hydrogens. And let's try the condensed formula. So it is courtesy to represent the C-to-C double bond along the condensed formula, but you don't have to do this, but I'm just showing you this could be done. How about the second one? It is slightly difficult to see because all the hydrogens are not drawn, but I want you to practice drawing the hydrogens in and see if you get the condensed formula. And do you want to try the skeletal formula? Same, there's one stick represent 2 carbons because each end is carbon. So there's 2, 3, 4, 5, and we just gotta add a double bond in there. How simple is that? So second one, we'll do the same drill, 5 carbons in a row, and you guessed it, the double bond comes from the second one. Now you're ready to add side chains to an alkene. So we got 4 carbons in a straight chain, but containing C2C double bond. But adding a side chain, now you know it, this is a methyl group. And let's add hydrogens, because there are so many students who said, oh, I will add the hydrogens for the test, but they actually don't. So make sure you get into the practice of drawing hydrogens all the time. If you can't be bothered, just draw them as a stick so you know it's there. So we got 4 carbons, you guessed it, numbering from the side that's close to the C2C double bond, so it becomes a but-1-ene, which shows the location of the C2C. But there is a side chain of the methyl group coming off the second carbon, so it is called 2-methyl-but-1-ene. What if you move the side chain to somewhere else? For the alkanes, we were counting from the side that's closest to the side chain, but in an alkene, the double bond gets a priority, so always make sure to count from the side that's closer to the C2C double bond, not the side chain. So here we are, we have methyl group coming off the third carbon, so it becomes 3-methyl-but-1-ene. By now, it should be getting easier and easier for you. So we got 4 carbons having a double bond here, so this will be but-2-ene. And this time it's a symmetrical alkene, so it doesn't matter whether you count from left to right or right to left, so you can actually choose your choice. And there are hydrogens again, and skeletal formula. Can you recognize it now? So let's add the side chain here, since it doesn't matter which side you count from, but this time the methyl group is closer to the right, so it is important to number this from the right to left. So methyl group comes off from the smallest number, which is the 2-methyl-butene. And this brings to the last slide of the alkene, and let's have 6 carbons and randomly putting the C2C double bond and an ethyl group and a methyl group. So remember to prioritize the C2C double bond. So there are 6 carbons in the main chain, but it's important to consider all other options. So if you count this as a longest chain, they still have 6 carbons in a row, but it makes things difficult because there's a side chain off the side chain, which makes it quite difficult to name. So I'm going to choose the straight chain to be the main backbone of this. So there's a double bond between 2 and 3, so that becomes a hex-2-ene as a main chain. But there's a methyl group coming off the number 5. There's an ethyl group coming off number 4. So remember, when you have a multiple side chains, we prioritize the alphabetical order. So ethyl comes before the methyl, and there's a dash between the alphabet and numerical number. If you're still thirsty for more naming of alkenes, let's get into the more complicated story by having more than one C2C double bond. So having 6 carbon, we'll always start with a prefix of hex, but there's a double bond and I'm adding another double bond. So counting from left to right, and this carbon double bond starts from 1 and 3. And remember, there are 2 C2C double bond, and I'm going to add hydrogens. And the naming goes hex 1,3-diene. Does it make sense? The C2C double bond starts on first and third, and having 2 double bond will have diene, and molecular formula slightly changed. The number of hydrogen is no longer double of number of carbons, so it's supposed to have 12 hydrogens, but since having that extra C2C double bond, we're lacking 2 more hydrogens, so this one will have a general formula that's very same to alkyne, which is 2n-2. If you study IB or AP or Cambridge, this might be quite handy. We're dealing with cyclostructures where carbons are looping into something like a cycle. Doesn't have to have 6 carbons, it could have any number of carbons from 3 because triangular is also considered a cyclo structure. But since it's a cyclohexalkene, you've got to have a C2C double bond. And you can count them from any carbons, any 2 carbons that are doubly bonded. So I'm going to start counting from 1 and 2, and rest of them goes like this. And adding hydrogens there. And this is still hexene, but since it's a circular structure, we just have to put cyclo at the front, or you can even call that cyclohex-1ene to show the position of the C2C double bond. Now the skeletal formula looks pretty similar, and we just show an extra double bond there, and molecular formula is still the same as alkyne because a cyclic structure also gets rid of the 2 hydrogens. If you are taking IBHL or A2 level in Cambridge, stay tuned because I'll be looking at the benzene structures. So it has 6 carbons in a loop, so it's a cyclic structure, but we have an alternating C2C double bond on the every second or carbon. So you can start counting from here, there, or there because it's a really symmetrical structure. But since I've got number 1 here, I'll start counting from there. It brings the structure of cyclohex 135, having 3 C2C double bond, becomes a triene with only 1 hydrogen on each carbon. So skeletal formula, you might be familiar with this structure already because this actually is present in many structures. And molecular formula goes C6H6. And you might see those double bonds alternating, causing our resonance structures, and this has actually 1.5 bonds. So you heard about C2C single bond and C2C double bond, but in fact there is something in between which is 1.5 bond. So if you're panicking right now, don't worry because I'll be making another video on the resonance structures, and this structure is called benzene. For those of you who are really striving for highest grade, there's an extension which deals with multiple different functional groups. So let's check it out. I've got 6 carbons in a row, and now you should be familiar with the CC double bond. Now bromine is added into it along with NH2 group. So you don't have to know all the functional groups yet, but I'm just showing you there's an alkene called alkenyl group, and there's a bromine which belongs to halogenoalkane because bromine is halogen, and if you're taking other system it might be called haloalkanes as well. And there's an amine group which is also referred as amino group, so prioritizing the CC double bond over halogenoalkane and amine, so we need to number them closer to the side that has a CC double bond. So there's 1, 2, 3, 4, 5, 6 as a main chain. I won't do the hydrogens for now, so this is hex-1ene. So number 4, there is a bromine coming off. Actually, I'm going to do the hydrogens just to be a good model. So there's a bromine coming off 4, and amine, when it becomes the side chain, that will have a prefix of amino coming off the 6th carbon. And remember, alphabetical order prioritization, so amino comes before the bromo. So that is called 6-amino 4-bromo hex-1-ene. How cool is that you can name them all now? This brings to the last class of hydrocarbons made up of carbon and hydrogens. So C2C single bond represents alkane, C2C double bond represents alkene. You guessed it, this one brings C2C triple bond. And fortunately, there's no more after this because there's no such thing as C2C quadruple bonds. So the naming goes exactly like an alkene, but with a suffix ending with YNE to represent the alkyne. If you want me to make another video going through how to name and draw the alkynes, please let me know so I can make it just for you. I hope this video really helps you, and thank you very much for watching.